doing all the exercise. I'm actually gonna do all the exercises. If this is gonna be a 6-hour video, it's gonna be a 6-hour video. Okay, we are going to do all the exercises for 3.6 for chapter 3 because linked lists and recursion are very important in anything. Okay, so we're gonna do all this. Okay, let's modify the implementation of class scores so that at most the upper floor of max entries over 2 can come from any single player. Okay. You guys can pause the video for game entry. Just copy this down. Pause it. Pause it. Here's the scores. Oh, I gotta get the scores. Okay, so we got that. You guys can pause it if you want to look at it. Pause it if you want to look at it. Pause it. Oh, okay. So now what was the question? What was the question? So modify the implementation of scores. So let me go to scores. Okay, so the single player is this. I don't know what that means. I don't. Let's go to the next one. Suppose that 2 entries of an array A are equal to each other. After running the insertion sort, will they appear in the same relative order in the final sorted or in reverse order? Ooh. This is B. How will they work? Okay, so insertion sort was, I could just pull it up here. Okay, so we're going to loop from here to here. I is equal to 1. I is equal to 1, right? J is equal to 0, right? J is greater than or equal to 0, yeah. And then A at J. So A at J is B. Is B greater than current? No. B is not greater than current, so this is not going to run. So now J plus 1 is going to stay there. Okay? So yes. So now we're going to go to the next one. This one. So I is now 2. J is 1. J is 1. Okay, so J is 1. J is greater than or equal to 0. Yes, it is. A at J. What is A at J? A at J is D. While D is greater than A. So yes, it is. J plus 1, which is here, becomes A at J. So this becomes D, right? And then you decrement J to be 0. So J now becomes 0. J now is 0. Okay. A at J at B. Is B greater than A? Yes, it is. B is greater than A. So J plus 1 becomes B. So this is B. J minus minus is 0. Okay. Now then we change this to current, so this becomes A. Okay, so it's B, D, A. So this A is still the same. Okay, now let's see if this A gets in front of this A, then that means it's out of order. If this is still behind this A, then that means the same order. Okay, let's go on. Right. Okay, so I is at the end. Current is A, right? Current's A. J is equal to whatever index this was, which is 0, 1, 2. So J is 2. While 2 is greater than or equal to 0, which it is, A at 2. D is greater than A. J plus 1 is going to equal to J. So this becomes D. Okay. And then J minus minus. So 2 now becomes 1. So now we go here. Okay, is B greater than A? Yes, B is still greater than A. Okay, so we set this to B. This is B now, right? Okay, then J minus minus. Okay, now it's 0. A at 0 is A. Okay. Is A greater than A? It's not. So then that means J plus 1, which is J0, right? J plus 1, this is now becomes A. So it doesn't become out of order because this A is still on the right side no matter what. So yes, it's still in sorted order. At least that's what I think. Okay. Given a C++ code fragment that gives a matrix n by n of type float, replaces m with its transpose. Try to do this without the use of temporary matrix. This now becomes 1, 3, 5. Oh, okay, that's not that bad. Okay, so in order to do that, we could do this. Okay, so if I want to give code that creates a transpose. Alright guys, so I got the thing to work finally in the end. So look at our array. So before transpose is 1, 4, 2, 5, 8, 3, 6, 9. After transpose is 1, 2, 3, 4, 5, 6, 7, 8, 9. Every single row became the column. So I'll tell you how I did it. So first I did this by first realizing, okay, well, if I could flip this over, all this is basically just flipping it over this axis, right? So I loop through, originally I looped through from row, from 0 to the sides for row and column, so it would do 0, 1, 2, and then 0, 1, 2. But then I realized that wouldn't work, right? So then I was like, okay, so how do I do this? So first I did it by, through this diagonal, that 1, 1, if it's the same row and column, like 0, 0, 1, 1, 2, 2, you're not switching them. You're only switching 4 to become 2, and this to become 4, right? And then this to become 7, and this to become 3. You're only switching everything from diagonal of this, right? So in order for so how did I figure it out? Well, I basically listed all the things that I had to do. 0, 1 have to be swapped with 1, 0 at row 0, so at row 0, 1, 2, and row 0, 1, 2, right? So at row 0, 1, this has to be swapped with this. Then I was like, okay, at row 0, and then column 2 has to be swapped with 2, 0. It's like, okay. Then I realized, okay, wait, at row 2, 1 has to be swapped with 1, 2. I was like, oh, okay, well that's not that bad. But then it just stops there, right? So I was thinking, how do I get the combinations of doing this? So I thought to myself, well, in order to get the combinations, let me just comment this out. Originally, it was column starts at 0, go here, right? Then I wrote the code to swap it. So I get the current value at the row at 0, 0, and then 0, 1. And then I get the current value at this side. So I get the current value I'm at. Then I switch this with 0, 2, switches it. Then I switch this with 2, 0, so this becomes 7. And then at 2, 0, it becomes 3, right? So I did that here. So I said current equals to row at row column. I said row column is equal to call row. Then I said call row equals to current. So that's what I did here. But then I realized, okay, wait, I can't do that because the thing is it keeps going. So then I was like, okay, wait, how can I do this? So I thought to myself, how do I get all the combinations of row and column? Here, basically, it's all the combinations of row and column here, right? It's 0, 1, then 0, 2, and then 2, 1. That's basically it. So I was thinking to myself, how do I do that? Well, I started with 0 row column, right? And then originally it wasn't like this. So originally I was just like, okay, so I'm going to go through from row 0 to the end, and then column 0 to the end, right? Then I'm going to print out, okay, print it out. Only if it's not equal to each other. So what did I print out? Well, I'll show you what I print out. So I thought to myself, okay, well, I want to get all the combinations, right? So I looped through it. So here are the combinations just from looping through it, from row and column, and just printing them out row, column, right? Only the ones that are not row is not equal to column, okay? So I was like, okay, 0, 0, 0, 1, 0, 2, 1, 0, 1, 2, 2, 0, and 2, 1, okay? I wanted to skip them when they're equal. So I skipped when it's 0, 0, and when it's 1, 1, and when it's 2, 2. So I skipped that. But the problem here is that how am I supposed to get this so it's not repeating? Like, I don't want 0, 1 to be the same as 1, 0, right? Or like 2, 0 to be 2, 0, 2. So it's like, okay, well, to do it, all you have to do is have row start, column start at row plus 1. Because think about it. If column starts at row plus 1, then now what do you have here? So you skip the ones that are repeating. So 0, 1 is not the same as 1, 0. You skip that. So this is all the combinations that are not repeating. 0, 1, 0, 2, and 1, 2. So then I was like, oh, okay, well, I have that already. So now after I have the code, I basically just put the code for swapping the values at the correct index. And that's how it worked in the end. As you can see when I uncomment it out. Before transpose, it was 147258369. After transpose, it was 123456789. Alright guys, we're going to do the second part. Describe a way to use Recursion to compute the sum of all elements 3D array. The ones where describe it, I'll just tell it because there's way too many questions. But this one, I think I could figure it out. So we're going to keep calling this, and we got to... So if row and column are both equal to 0, then we're going to return Otherwise, we return matrix row column plus matrix at. We're gonna stay at the same row. We're gonna add it up. We stay at the same row. We gotta add up column. So column plus 1. But we also want to go down. We want to do if column is equal to 3. If column is equal to 3, that means we got past it. Then that means we're gonna return matrix row plus column. Oh, I didn't mean this. So this is this is just gonna go to the right, right? This one is when this is when the column goes to the right, and this is when the row stays the same. So column is equal to 3, that means to the right. We are going to set column back to 0, then row is going to right. So that means return column back to 0, and then row plus 1. I don't know if this would work. But now let's say if row goes to 3. Wait a second. No. Okay. If row and column are both equal to 3, then we return 0. Okay, if row and column both equal to 3, return 0. Because that means we're at the end. Then we check, otherwise, if column just equals to 3, because there's, okay, let's see. Let me bring up Notepad. So let's say you have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And it's indexed at 0, 1. So we're going to keep going to the right. If row is equal to 3, okay, if row is equal to 3, then we return 0. Alright, screw it. Well, let's just test this out. If it doesn't work, then we gotta... Okay, let me just delete this. 45! Ooh, is that right? Tell me it's right. Tell me it's right. Okay, what's 1 plus 4 plus 7 plus 2 plus 5 plus 8? Yes! We got 45! Okay, so we did that right. Okay. First try, guys. That was pretty good. Okay. That's pretty good. Okay. Give a recursive definition of a singly linked list. What does that even mean? Oh, node, if it's null, do something else. Recursive case, do something, call something else. Okay. Recursive algorithm. That was it, I guess. Add a function size to our C++ implementation of singular linked list. That's not that bad. So just in singular linked list right here, just have a variable called size. And every time you add something, just plus 1 to the size. So then the size would be a constant time. We have an algorithm for finding the penultimate second to last node in a single linked list where the last element is indicated by a null next link. Oh no. In order to do this, you have to do while next is not null. Because they're saying the last element is indicated by a null next link. So this is the next link. So let's say the last of the next is null, right? So if you have to do, once you get to 2, you have to check this next, then next. So current while current next at next is not equal to null. Then go next, current, and go to the next. And that would pretty much help you get to there. Yeah, that's how you find the second to last. Give us a generic implementation of a W linked list structure by using a template class. You just have to replace everything with the data with the E, and then just have that template thing in the front. I don't think that's that bad. I don't want to code it because it would take a long time. Give a more robust implementation of the W linked list class, which throws an appropriate exception if an illegal operation is attempted. What does that mean? Throws an exception if an illegal operation. What does he mean by illegal operation? Like deleting null? I guess you could do that. Just so they said in 3.3, this one. Just if you're adding a null element to the front or to back, just throw an exception. Also, if you get the front, you have to check if it's not empty. If you add, make sure it's check a null. Yeah, just check a null and then throw an exception. I'm not doing that. Describe a non-recursive function for finding by link hopping the middle node of a linked list with a header and trailer sentinel. No, this function must only using link hopping. How would you do this? Well, I think you would have to keep going from... Okay, so you have the head and tail, right? I'm just going to describe how it works because I don't want to code it up for now. Whoops. So you have the head and tail. Well, this is how the book implements it. So you have the head and tail. Basically, you just have to keep checking. You're trying to find the middle one, right? So just keep checking while head's not equal to tail. Then you keep going to the right. Yeah, you would keep going. You would call heads next. So then it would go here and here. And once it goes to here, to get to the middle, you would, what do they want to do? You would just return whatever is in the middle. So I'm assuming it's an odd number of linked lists because they want the exact middle. Over here, if it's 2, I'm guessing you just return whatever. So yeah. While head is not equal to tail, I think just keep going heads next and then tails previous. Yeah, so you could do that. Let's see. Describe a non-recursive algorithm for finding the maximum element in an array of... describe a recursive algorithm. Okay, that's not bad. I might code that up actually. See, okay, so if index is equal to 2, then I return the end, right? Else, I am going to check if matrix at index, so if the maximum number at the right is greater than the, so check if the maximum number at the, so we're going to go to the right. If this is greater than matrix at index, then we're going to return matrix at index. And else, if it's not greater than that, we're going to return matrix at, this is not making, okay. So we're going to get the maximum number of the right side, right? If it's great, if this maximum number is greater than this, then we're going to return maximum number. Otherwise, we return our current number. I don't know if this would make any sense. I don't think this would work. It works! Okay, let me try it. Let me try with other integers. Yes, okay, so we got the maximum number. Draw a recursive trace for this function reverse array. 0 for reverse array for the code fragment 3.39. Reverse array, code fragment 3.3 on array. A46. Okay, so there was definitely, I think it was recursion. Linear sum. Oh, right here. Okay, so they want us to do this. Okay, so we could do this. We could do this. Just don't mind my handwriting though. Reverse array. So let's go back here and then let's just find where, and 5. And now we want to reverse the array. And we're going to pass in A04. So A, this is A04. Okay, we're going to do this, the stack trace. What was it called? So we pass in 4 in here. So we passed in 4, but then, okay, so did 04, right? Now we're going to do, let me just delete that. Okay, so that swaps. A now has 5, 3, 6, 2. For that, the reverse array does A 1, 3. 1, 3. 1 is still less than 3, so we're going to swap 1 and 3. 5, 2, 6, 3, 4, 5, 2, 6, 3, 4. Once we have that, it's going to swap. It's going to call 2 and 2. It's I is not less than 2 is not less than 2, so then it returns. So that just returns this, which is this thing swapped. Okay, puzzle solver. Ooh, this is gonna be a good stack trace. Alright guys, so instead of actually doing the stack trace with you guys, or the execution of the function puzzle solver 3su, and where s is empty and u is equal to a, b, c, d, I actually took the time and coded it. And the thing is, it took me a long time to program it, but I'll just show you guys the algorithm first, and then I'll show you my code. So I think you guys should be able to program this, but it took me a while to look up some data structure to use. So here's what I did. For the first part, for each E and U do, you can't really use a regular for loop, because the problem is that you're removing E from U. If you use a regular for loop, well, if you remove it and add it to the end, that creates problems in C++ for each loop. Also, you're adding it back to U. The E is now unused. You have to find a way to be able to differentiate between unused and used. Otherwise, you're going to have a Stack Overflow, because then they're just going to keep moving it, adding it back to U, and then they just keep going on forever. Like if you have A, B, C, and then you take out C, and then you do the same combination for C again. Once it goes back to A, B, C, that's what happens. Like if every single E is used in U, then the whole loop is terminated. So here's what I did. There's actually a data structure called a map, and it took me a while to search it up, but I created a map. What is a map? It's basically like an array, except instead of whatever index you're representing it, you're representing whatever pair you want to represent. So here is like character, so whatever character at that index, I set it to an integer. The integer represents if it's used or not. So before this whole method, I make sure that I set everything inside this map to have 0, because that means that it's not being used, right? Because like you start the whole thing off, the loop, and you didn't use any of them. Then when you add it back in U, I set the used to be 1. So I had created a boolean called check element is not used. I assume they're all not being used, right? While there's at least one that's not used, then what do? First, I had another method also that just checks if it loops through the array of the map being used, and it checks if there's at least 1 0. Because if there's at least 1 0, that means this loop has to keep going. If there's at least 1 0 that is not used, then this loop has to keep going, right? Because we're doing every single time if we have the E's that are not being used. So then you have it being used now, and then after that, it's not being used, right? So I did that. What do I do first? I get the element at the first position of U, which is what they do here. Remove E from U. So first I have to get the element E from U, the first element of E from U. Then I had to search through the whole, there's no other way to do this, but you basically have to search through the whole position of U in order to remove it. This is what this is basically doing. It's an iterator that searches through the whole position in the set U. U is not really a set. I made them vectors instead, because the set in C++ does not have a pushback, which adds it into the back. They don't have that. That's why I made it into vectors instead, and it really didn't matter if it was vectors or sets, because unless you have duplicates, but I don't even think that we're caring about this at the moment. So I find the element, then I delete it, like what they said in the source code. So if it's not equal to end, that means I didn't hit the end, right? Then I delete it. I do this just to check if the element was not found. Then after this if statement, after these two are just to erase, remove E from U, I add E to the end of S. So how do I do that? I just do s.pushback element. Pushback is a method in vector class that allows you to add the element to the end of the vector. So I told you about vectors that it's a better version of array, because it allows you to add elements to the back. That's why. And it still has the same functionality. Here it says if k is equal to 1. What I did was I have k is actually represents size. So if size is equal to 1, they say test whether the S is a configuration that solves a puzzle. Well, I don't really have a puzzle to solve. So what I'm doing is I just say it just solves it anyway. I'm supposed to return solution found S, right? S is all the elements in the set. So what I do here, I create a string called solution found, right? And I loop through the whole thing of S, and I concatenate every single element in S onto this string solution found. If it's not the end, the last one, then I add a comma. So that's what this is doing. This is just going through everything inside the elements of S, and I'm just appending it. Then after that, once I'm done with all the elements, I add the brace, and then I print out to return, and then I just return, just like what they do here. Otherwise, I call puzzle solver again, which is what they do here, and I subtract 1 from the size, and then I pass in S and U again. Then after, when you call puzzle solver that many times, you're supposed to add E back to U, right? So I do U.pushback element, right? But I also want to set the map that I have at that element position to equal 1, because that means now it's used already. The ones that are unused are now used. So this right now is used at that element. Then I have this function called check element if it's not used. It's a function called 10 used, and it returns a boolean that checks if there's at least one element that's not used. I just call that function again here, 10, right? So it just checks if there's a 0. If there is, then I return true. Until the end of the loop, then I return false. So I do that, and this basically helps you get out of the while loop until all of the elements are used. If they're all are ones, then this loop breaks. While loop, it exits. So yeah, then you have to erase the element from S. So I use this iterator again. I loop through every single position in S to find the element. I check, does the position not equal to end? That means I found it. I erase it. So you have to erase and remove E from that end of S. And that actually ended up working. I'll test the method with ABC. So it gave me ABC, ACB, BCA, BAC, CAB, CBA, and that's all of the calls in this example. ABC, ACB, BAC, BCA, CAB, CBA. So yeah, that means I coded it correctly. So that took a long time to solve. Let's go on to the next question. I think this is actually another exercise to actually code up the algorithm. Yeah, you're supposed to solve it by testing all configuration. I already coded this, so technically I don't have to do 3.6. But yeah. Alright guys, so after 3 hours I was able to figure this out. I basically had a problem of resizing arrays. I didn't finish it all of yet, but basically to remove an entry from an array so it holds no elements, you basically have to resize the whole array. And I'll show you guys, I figured out how to do that. Before I start, I have an array called array. Has 1, 2, 3, 4, 5. What I realized that if you pass an array into a function, you can't set that array to a new array. It's not a pointer, right? So I had created a pointer that point to this array. Then I'm just printing out all the values of the array, and I call this function called remove at index, and then I print all the values after the array. So here in this function remove at index, thing is about arrays is that if you pass it in as a parameter, it's passed by reference, but the thing is that you can't really set it to another array. At least when I tried to do it, it didn't work. So what I had to do is I had to make it a pointer and then create a reference to it, okay? I had to pass it by reference. And then I have the index that I'm removing it at, and then the length. I allocated memory for a pointer to have 1 less than the length of the current array. Then I'm going to loop through. I create an index called temp. And this is basically going to go through every single value from before whatever I'm moving at and then to after whatever I'm moving at. So let's say I have, in this example, I'm going to have 1, 2, 3, 4, 5. So I have 1, 2, 3, 4, 5, right? And basically I allocated this temporary array called temp. This is temp. This is my array. I allocated 1 less than the length. So the length is currently 1, 2, 3, 4, 5. So I have it 1, 2, 3, 4 because it's 1 less, right? Then I create an index called index temp. So this is going to start from 0 and it's going to keep adding 1 every time setting a value in this array. I'm going to loop through from 0 to the index that I'm removing. So let's say I'm removing 3. This works at the front or the back, right? So I'm going to loop through from 0 to 3. Then I'm going to set the temp at index temp, currently is at 0, to have the value 1, because I'm looping from 1 to 3. So I'm going to have this have value 1, and then I'm going to add temp by 1, index temp. So index temp is going to plus plus. This is called post incrementing. So it adds 1 after the statement is executed. So then after that, I add 1. Now I have 0, 1 here. Temp index is at 1. Now I'm going to set the value at temp index at 1 to 2, right? So originally this is going to set this value to have that. Then I'm going to have 2, okay? Because I'm setting the temp index at 1 to have the value at 0, 1, right? Then at this index, right, it's going to stop. Then I'm going to loop through from whatever I'm removing, which is 2, to the end right here, and I'm going to copy all the values after it. So this loop copies all the elements before the one I'm removing. This copies all the elements after it. So that's what I do here. So I'm going to copy every element after this. So that at index temp 2 right now, I'm going to set it to have the value at the index 3, which is 4. And at 3, I want to set it to have the value 5. So that basically removes this element that I'm removing. I'm trying to remove 3 currently. Then I reassign the old array to have the value of temp. So that technically works because I'm passing it by reference now. the old array actually gets changed. I'm thinking about should I free the old array though, because if I do that, that might stop a memory leak. Let me just see if it works. If it doesn't work, then that means I didn't allocate memory, which that would make sense. Yeah, okay, so that makes sense. It won't work because I didn't use the new keyword to allocate memory for array. I just passed it in like this. This is technically not really allocating memory. Okay, so that removed whatever index I'm at. So look, so I first here currently I call the code removing at index 0. So before the remove is 1 2 3 4 5, and then I at index 0 I removed it, so 1 is gone, so it has 2 3 4 5 now. This was the code to remove at a certain index, but that's not what they want us to do. They want us to write a short C++ function that repeatedly selects and removes a random entry from an end element array until the array holds no more entries. Now I'm going to create a new function called remove at random entry. It's going to call remove at random entry, and it's going to have the same thing here. This is going to be a recursive call. It's going to keep calling until length. If length is equal to 0, then it'll return. I'm going to keep calling this function until the length is 0. I'll just pass in length. I'm going to do length minus 1. What am I going to do for here? I am basically going to, so I'm going to keep calling this function, but I'm going to call remove at index. And what is this going to do? Well, it's going to pretty much recursively call this function, remove at index, and I'm going to get a random number between 0 and length. Okay, so this generates between 1 and 10. Okay, so I want to generate between 0 and length, so that would just be, does between 0 and length, and that's what I want, int index. Okay, so I did that. Now I'm passing in. Okay, so it's going to remove at that index until the length is 0. Remove at index has to be above the function. Whoa. Okay. Something happened. I don't think I should have passed in a vector. Then I don't even have to resize, because then I could just remove it. Okay, so before remove, it prints 1 2 3 4 5. So I'm actually going to print the values every time I remove them. Just to make it more clear to you guys, I'm going to print out the number at the index as well. So array at, after removing number at index, need a number removed is going to equal array at index. So that's the number I'm removing, and then I have to print this out. The reason why I put it after, because if they remove after the index, then yeah, they'll have trouble with that. Okay, so printing all values after removing number 4 at index 3, which removed number 4. Printing all values after removing number 1 at index 0, so that printed these values. Printing all values after removing number 3 at index 1. Let me just make sure you guys clearly see what happened. So before removed, you have 1 2 3 4 5. Printing all values after number 1 at index 0, so that removed number 1. This worked in the end. It removed all the values based on random numbers from 0 to length. That was very hard. These exercises are very hard. Okay, so let's go to the next. Give a generic implementation of a circular linked list data structure. I'm not going to do that. That's just adding a template. Give it more robust. Throw it illegal if illegal operation template. I'm not doing that. That's just throwing if it's null or something. Write a short C++ function to count the number of nodes in a circular linked list. Alright guys, let's write the next question, which is write a short C++ function to count the number of nodes in a circular linked list. So I'm going to copy the code for a circular linked list, and then I'll write the function that's supposed to count the number of nodes in it. Alright, so here is the header file for every single node. If you want to pause the video, you could copy it. And then, oh no, not node, this is a circular list. This is a list, okay? And then here's the header file for every single node if you want to copy it. I think they should have a constructor here, but that doesn't matter. Here's the implementation file for the circular list. You could copy it. Did you copy it? Okay. Pause it, copy it. And I gotta scroll down to this part. Let me just scroll down. Alright. So please pause it and then copy the code down. Yeah, that was pretty much it. There's nothing in this because they don't even have a constructor or destructor for the node. So yeah, that's the thing. Alright, so what do we have to do now? Well, we have to create a size function that's recursive, so we'll have a size function. but it needs to have a node as an element. So I'm going to pass in C node, circular node, and it's going to pass in okay, so we'll create one for this, the regular size, right? But then I want to create a auxiliary function for size also. What is auxiliary function? It's basically just a helper function for you, help your size. Let me just go to my circular list. I'm supposed to have an implementation here. Shouldn't it give me an error? Okay, well, it didn't give me an error, so that's very strange. So I have to do circular list size, and then is it gonna be const because it's just returning 1? Actually, it doesn't matter. I don't think it matters. It's an int. Okay, so we have that. Now what am I gonna do? I want to create a private function for that. So I'm going to do int circle list size augs, and it's going to take in a C node as a pointer to a C node, and this is going to be called current. And then for the size, I will just return this auxiliary function, but I pass in the head for it, the pointer to the head. So it will be what did I call it originally? What was it called? Oh, cursor. This point to cursor. Okay, so I'll pass in this, and then cursor. Okay, and then here it's undefined because I didn't define this in the header file, but I'll define it now. Just make this private. This is going to be size augs, and it's going to take in a C node cursor. Okay, now this should be fine. Wait, I said private twice. Can I do that? I don't know. Maybe can I see? Let me see if I can put it in here. That would make more sense. Okay, now let me go here. Okay, so now this is fine. Okay, so it's gonna call size auxiliary, and it's gonna pass in the cursor. So in a circular linked list, the code for it, let me just go here and just get the code for the circular linked list. The difference between is that you have a front and you have a back, and the cursor goes that. I want to get the front first and just keep going until cursor hits to the front. Until cursor hits the back or the front, whatever. I don't think I just keep going until I go back to the same cursor. So I just do that, okay. So I'm just gonna keep going. I'm gonna call this again. Call this function again. This time I'm gonna go next. I'm basically gonna keep going. Why can't I do this? It's a node. Cur. Oh, did I call it auxiliary? Maybe I did that. No, it's a cursor. Oh, wait. Why can't I do this? Okay, yeah, so I'm gonna keep calling this. And then if cursor's next is equal to cursor, then I return 0. So if cursor's next is equal to cursor, well, that one makes sense. Okay, the problem about that is that, okay, so I have to keep going next until I reach back to the current. So I need the current one. So maybe I should have a variable called current. That's a cursor. Then it's gonna keep calling until I hit. No, that doesn't make sense. Let me think. Let me think. Let me see. So I want the cursor to keep going forward. But once it goes back to the front, then that means that it's ended. So if cursor is equal to front, so is there a front function? Is there a front? Okay. I just take this. I shouldn't call this cursor. This should be current. That would make more sense. Where's my circular link list? Should be current. Okay. So if current is equal to if current's next is equal to the front, then that means that I'm done. I'm done with the list. So where's the front? I'll just call element list front. Then I'm done, right? Okay, so I have to do element. I'm hoping that they override equals equals, because if they don't do that, this might just check the pointer. But yeah, okay, so if the cursor's next is equal to the front, I return 0. Because that means I'm at the end. Otherwise, I call this function with the next, I do return 1 plus, call it with the next. Okay. I don't know if this would work. Let's just test it. Okay. So what I'm going to do is I'm going to create. Whoa. Okay. So I'm going to. This is a lot of code I wrote. It's a lot of code. Okay. So what I'm going to do is I'm going to delete this. No, not this. Delete this. I'm going to create multiple circular link lists. Let's just see. Should I use new? I don't want to manually do it. I want to dynamically allocate memory. Okay, let's just see if can you do it. Circular list. My list. What's the problem? It's undefined. Okay, so I have to include the header file. What was it? Circle list.h. Okay, so I included the header file. What's the problem now? Okay, yeah, circle list, my list. So this creates a list. This means that it created a list of with cursor being null. Now I want to add. Gonna add elements. I want to add some elements. So I'm gonna add. So this uses E. This is generic. Is this a template? I don't even know. Okay, I'm gonna add element 1 or something. I have no idea. So my list.add. I can't do this. Why? Because this is a string. Oh, okay, fine. Okay, add A. Okay, then I'm gonna add B. I'm gonna add C. Add D. Okay, now I'm gonna print out the size. I'm gonna call the size function my list. Size. And see if the size is 4, then I did it right. So current, my size is, okay. Build error. Okay, let me see the build errors. What are the build errors? Must be declared in node first. What does that mean? What? Oh, okay. Well, I can't even define this, so yeah. Alright, what are the build errors? Okay, what is this? A linker error. Ah. Okay. What line number? Remove extern for remove void. What about this? Okay, so I have to find this error. So guys, I'm gonna try to find the linkage. Okay, so the big problem that I had before was that I didn't copy remove, and that's the reason why this linkage had this error. So here, I just copied remove, and let me just take out this, take out this, take out this. Okay, so here's the remove function. You could just copy this down, and let's see if we could run. Just care about running. Doesn't have to work. Did the source file work? Execute. Well, it says there's an exe, so my size is 0. Oh, okay. So it didn't add anything. That is strange. Okay, so our size is not working. So let's just run debugger one by one. I think it's not F10, that's F11. Okay, so let's just F11. So we call this cursor, and I didn't press F11 again. Let me try it again. So F11. So we call this, what is curs next? Curs next is D. What's cur? Cur's A, its next is D, its next is C, its next is B, its next is A. Okay, so if okay, this is just C stuff. I went too far in. Okay, so it turns 0. Damn. Okay, so why did it do that? Why did it do that? Let me try it again. Okay. I'm gonna keep trying until I get somewhere. Whoops. I gotta stop making that mistake. Okay, F11. Go in. Go in. What is curs next? Curs next is D. What is front? This front. Oh. Oh. It shouldn't be curs next element is equal to the front because right now what's happening is that front is returning curs next element. Curs next element is always going to equal to curs next element. Okay, so the front, so currently front is curs next element. So let me just go back here. So this next, just cursor, right? Its next element is front. So cursor is pointing to the back. Okay, so if I want to, I have to check if curs next is equal to cursor, which it won't work. Okay, no, that's not what's happening. Okay, so I have to check if current is equal to cursor. That's what I have to check. Because current is the head. I passed in the current's head, which is what was current? No, I passed in the cursor for current. I passed in cursor for current. I should pass in cursors next for the front, for the head. Because this would be the next. Okay, no, okay, just to make it more clear, I'll pass in, yeah, okay, yeah, so this is going to be the head. This cursor's next. So, here I'm going to check whether, so this is current, right? Whether current is equal to the front. Current is equal to cursor. If current is equal to if current points to cursor, the same object as cursor, this cursor, just to make it more clear. So what's happening? Okay, so we have this size, right? We pass in current, which is the current node I'm at. So I passed in cursors next, which is front. So current is going to point to this front, right? And I'm basically checking if current is equal to this cursor, which is this, right? Then I return 0. Otherwise, I return 1 plus current next. And this should work now. I hope it works. If it doesn't work, then I don't know. At least give me a Stack Overflow. Let's see. What do I have? 3. No, it's supposed to be D. A, B, C, D. It's supposed to be 4. What went wrong? What went wrong? What went wrong? Okay. I'm going to debug again. This is what I love about debugging. Debugging is so much fun. Oh, whoops. Let me try it again. 11. So I passed in cursors next, which is this is front, right? And then now I'm going to cursors next, D. Okay. And current is D, because I passed in cursors next. Okay. No, cursor's A. My bad. Cursor is A. Current is D. Right? Let me just see this function. Let's see. Okay, so we have, I'm going to draw this out just to make sure that I'm doing this correctly. Okay, so cursor point has the element A. So this is cursor. Has A. Cursor. Okay. Its next is D. So this points to this next value. Let's see next. This points to the value D. D. And D's next points to the value C. And then D's next points to C. And then C's next points to B. And then B's next points to A. And A's next points back to D. Okay. So B's next points to A. Okay, so we have that. That's some BS. Okay, so we do this. Okay, so what is current? Current is, I did cursors next, which is D. So current is this. I made it point to the front. Right? The current node. So what I'm having is I have a cursor and then a current. So I'm checking it. Does current is equal to cursor? No. So it's going to do 1 plus the next value. Does current is equal to cursor? So now I went to the next value. So now current is this. So move it here. Current is now this, right? Does this equal the cursor? So current is C. Yeah. Does it equal the cursor? No. So I'm going to return 1 plus this next. So now it's going to go here. Does current equal the cursor? No. It's not. Current is B. Cursor right now is A. Right? So let's go to the next one. Does current equal the cursor? Yes. Okay. So we're going to return 0. So this returns 0. So now I have 0 plus 1. Zero plus 1. And then that's 1. Then plus which one is this? Oh, current. What is current? Current is now C, so that's 1. Now 2. Now wait. Now 3. So that's 3. And then current's D. Oh. So when I get to the end, I should return 1. That's what I should return. Because they're the same node, right? So here, I'm going to go back to the score entry, the cursor list, and I'm going to return 1 this time. Okay, and this should ideally work. Work. Okay, size is 4. Yes, okay, so that worked in the end. Okay,